So what is the difference between a list and a set anyway? Today we're going to be talking about all things data types. We are taking things back to basics today. In this video, we're going to be looking at data types in both Terraform and Bicep. Now, I can't do this alone, so I'm partnered up with my friend and colleague Jack Tracy, who, like me, is part of the Azure Landing Zones and Azure Verified Modules teams here at Microsoft. We're going to start off with an introduction, followed by some hands-on stuff in both Terraform and Bicep. It's a bit of a longer one today, so we've put some chapters on the video to help you navigate. I hope you enjoy.
So Matt, anything to add around data types? Like, obviously pretty fundamental, right? Like probably the first thing we all have to learn, but probably all skip past very quickly.
Yeah, I agree. I think it's really important to learn the nuances of data types for your particular infrastructure as code language. There's some real oddities, I guess you'd probably call them, in Terraform and in Bicep too. So yeah, when we come on to, how do we have a decimal number in Bicep, or what's the difference between a list and a set in Terraform? That's what we're going to get into today. It can confuse a lot of newcomers. So yeah, we hope this is useful.
Absolutely. And which goes without saying, we're going to get into some actual hands-on code as well towards the end. So make sure you stick around for those as well. So let's first jump into some of the core elements, or the foundational pieces, or the foundational data types. So we have strings, numbers, and Booleans. These are like the atomic values, right? You can't really get any smaller data types than these elements in any infrastructure as code language. Obviously, from a programming perspective, yes, you can, but we're talking infrastructure as code here. So a string is literally a string. Like, this is a string. You might commonly see it wrapped in double quotation marks or single quotation marks. A number you won't see wrapped in quotation marks. It will just be the number, the digit. So 3, 4, 5, whatever. And this is where actually we got some differences already between Terraform and Bicep. So in Terraform, they actually support some things as a number called integers and floats. So integer is a whole number, so 1, 2, 3. But a float is a number with a decimal place in it. It's got a floating decimal place in the number, right? Hence why it's called a float. So you could have like 1.5, 2.7, 3.9. Now in Bicep, that's not a thing that exists and is not supported today. And we'll get on to how you handle that at a later date. But you can't use floats. So there's only integers in the terms of Bicep. But in Terraform, it's just declared as number, right, Matt?
That's
as a
correct,
data type.
Just one type. And it works out the best way to store that behind the scenes if it's a decimal number or if it's a whole number.
Awesome. No, that's really good to know. And then we also have Boolean, which hopefully most of you are familiar with, which is literally true or false. Again, you won't see this wrapped in quotation marks quite commonly. It's just true or false. If you do see it wrapped in quotation marks, it's a string, right? But with the same thing. So just be aware of what these like little things mean. Moving on from this, we have some more composite values, things that stitch multiple values together, right? So in this example, we're showing here, we're showing an array or a list, as we may talk about in Terraform. And this is, as you can see, it's an array of strings. So it's 1, 2, 1, but they are all strings that are wrapped inside of an array. And that's shown by the square brackets either side of it on lines 1 and 5 here. In Terraform, they have to all be of the same type, right, Matt? So they all have to be strings?
Yeah, so if you're doing this in Terraform, when you define if it's a variable, you'll say it's a list, bracket, string in this case, and it'll be a list of strings. And if you try and put anything else in there, it will complain.
And that's where we get another difference again. In Bicep, you can mix them up. So I could have 1, 2, and 1 here declared as strings, and then I could put the number values or the integer in Bicep as 1, 2, and 1 as the digits, and that'll be absolutely fine. I can't say I would advise doing that. It's quite a nightmare to manage and work out what's where and what's there. But it can be done, right? And I think that's something just to note. Like, it can be done, doesn't mean you should do it. And then, Matt, we've got some differences on the Terraform side, right, around arrays, right? We have something else called sets. Do you want to give us a bit of an intro on those?
Absolutely, something that's oft confused. So sets come from, do you remember Venn diagrams at school? Do you remember them?
Oh, yeah.
Yeah, those who like apples, those who like oranges, those who like both. Well, the point is that those are all unique outcomes of that scenario. And that's what sets are. That comes from set theory. So basically what that means in the real world is you can't have duplicates. So you have to, every value in a set has to be unique. The other key difference is that it's not ordered. So if you took an array or a list and you you did a for loop over it, you'd always get things come out in the same order because that's
Yeah.
the property of the array or the list. Whereas in sets, you cannot guarantee it will come out in the same order. So you do not rely on a set for ordering if that is important to you. But if
That
you
could be
want
very
to be
fun in Terraform, right? Especially based on some of your recent videos around like don't use for loop or counts and stuff like that. Like that could be fun.
Yeah, no, absolutely. So it's a really good way of making sure you haven't got duplicate values though. You can just convert your list of strings to a set, and all of a sudden you've got a known unique list. So yeah,
that's a really good point. And actually, I missed the point on the previous slide around arrays that they're always the same order, right? So if we just quickly flick back, 1, 2, 1 here, they'll always be at position 0, 1, and 2. And I think that's also another key point to call out that we maybe have skimmed over is arrays. Each of these is known as an indice or an index, and they start at 0. So in this example, number 1 here is actually array index position 0. So always take off 1 when you're trying to access something in an array, and we can show you that later as well. And again, that's really important with the same with sets, right? They still have an index position. It's just obviously they'll be unique, I would take it, and you won't know what they are.
I don't think you. Yeah, I don't know actually. It's an interesting one. Maybe I'll try that in my demo later and see what I can.
Let's give it a go. Let's see what we work out. Yeah. And then we've got objects, right? So defined by squiggly brackets or mustaches, if you want to call them that. And these can contain different types, and they can also be nested. So in this example, we've got A, which is a string, B, which is a number or an integer on the bicep side, and we've got C, which is a Boolean here. And they can all be declared in a single object, and happy days. And you can nest it. So this could have an object of objects inside of it. And we're going to show you some examples of that also. In Terraform, they're called maps, right, Matt?
So these, if it's only a map if you've got kind of a nested one of these. These are called objects, but it's kind of a blurred line between maps and objects. It's a bit odd, but
yeah, if I said this is a map to you, you'd probably know what I meant.
Yeah, I would, but strictly speaking, it's an object. But yeah,
fair, cool, all right. And then we've got some. This is actually a map, right? So I think this leads on nicely. So over to you, mate.
It might sound really confusing, but ultimately a map is an association of a key and a value. Now in Terraform, and I think in Bicep as well, the key is always a string because it basically represents an JSON object. So what you're essentially doing is looking up a value by its key. We use this a lot in Terraform, as you will hopefully know for watching my video on using for each the right way. Map is the correct way of using a for each to get multiple resources. And what we typically do is the value of that map is an object with a schema which represents all the data you need to create that resource. So yeah, you can also have nested maps, so it gets really confusing sometimes. But yeah, I think hopefully this will make more sense when we come to the hands-on stuff and we can kind of show it for real, and it will hopefully sink in. Yeah, ultimately a map is just accessing a value by its key. So you can see an example on the screen. Actually, you've got my key, so we'd be able to access the A equals foo, B equals 3 data by referencing that my key, and we'd get that value out of it.
Yeah, and I think also a point of note in Bicep, this would still be declared as an object, but sometimes commonly referred to as a dictionary because you're using that key to look up the value. So you can think of it as a dictionary, right? You're looking through a dictionary to find the starting point to then get more data about that particular thing. So that's that one. And then we've got nulls, right, Matt? Do you want to talk to us about nulls?
Yeah, so in Terraform, any type of object can have a null value. Now, it's not the same as an empty value. So when you're making your expressions inside your Terraform modules, if there's a possibility that the value can be null, you have to test for both null and an empty list. So actually, it's a really good practice on variables that have collection values to set the nullable equals false property, because then if someone passes in a null value, Terraform behind the scenes will just change that to an empty list. So you don't have to cope with both those scenarios in your code. You can just assume that it'll either be a list with something in it or an empty list, rather than having to test for null as well. So yeah, null is normally used to say I don't want this in Terraform.
Okay, you won't quite see it that as often, I would say, in Bicep. From my experience, you'll quite often see people declare like default values for parameters as empty strings, insinuating that it's not needed, and then they'll have a condition that says, hey, if this is empty, then don't do this or do this. So we don't see this quite as often in the Bicep world, but nulls do exist for some properties of resources as well.
Just want to come back on that set point. I've been hacking away in the background, and because sets are not ordered, you cannot access their properties by index. So you can't go my set 0 because they're not ordered. You can't guarantee the order. You can't reliably get that value back. So yeah, there you go.
There you go, like on the fly learning, which we love. Absolutely. So I suppose, Matt, should we try and make this a bit more tangible, right, for people watching along? So should we dive into some Terraform first?
Yeah, cool. Let's do it. Okay.
All right. Let me get your VS Code up. Here we go.
Cool. So I've got a load of locals defined here, and I'm going to be using a feature of Terraform, which is way underused and is actually super useful, called the Terraform console. So I've got a local, I've got some stuff in here like my string, my empty string, my number is string. So we're going to be looking at some value conversion stuff, my bool. And you'll notice I haven't had to be explicit mostly about the types here. Terraform will assume that because I put true like that this is a Boolean. If I was declaring this as a variable, I would put the type, because it's good practice to tell Terraform what type it is. But with locals, you can kind of be a little bit more lazy about it. So Terraform will make these two numbers. It will make that a Boolean. It'll make that a string because it's got quotes. The difference is when I've got this thing like a list here, that's a list of strings. But if I was explicitly wanted to be a set, I will use the toSet function to say, no, I don't want you to be this to be a list. I want it to be a set. So yeah, we've also got slightly more complicated stuff like nested lists, so lists of lists. And then we'll move on to objects and stuff. So let's start doing stuff in code. So I've already run Terraform init here. So all I can do now is run Terraform console. And then I can just go local.myString, and it prints it out. So that's cool. We've also got some text functions here. So I can go lower local.myString, prints out in lowercase. Awesome. Nice. Yeah, easy. And we've also got interpolation as well. So if I go, this is interpolation, and then I go like that, you might have seen that syntax before. It puts the value of local myString into that string. So yeah, really common use case for building up strings containing, I don't know, resource IDs or whatever, right?
Names commonly, right? Like everybody's got a naming function with interpolation in it somewhere.
Exactly. So we got my number as string as well. So local.my number as string. If we've accidentally got that, you know, sometimes an API might return it in that format, or it's embedded somewhere else. So we can just use the toNumber function, and Terraform will return that as a number. Pretty straightforward, right?
Pretty straightforward. I was going to say, you're using Terraform console here, Matt. Like, this is not the only way that you could do this thing, right, of handling data locally. Like, we could declare it as an output and then run a plan and apply and get stuff out that way. It's just a faster way of doing it, right?
It is. It is a faster way of doing it. You could easily drop an output in here and just run Terraform plan, and it will tell you all the information at plan time, which is fine. But sometimes it's nice to just mess around with it in here. It's a bit faster, although you don't get the nice syntax highlighting like you do in the main editor. Let's move on to slightly more complex. If I load local.mylist, that's a list of strings. There you go. And local.mylist0 is hello. Mylist1 is world, right? So that's how you access the individual items in a list. Doing what we did earlier, my set of strings is this. Look at the order.
Hey, it's right? The wrong way around, right? It's almost like it's the first and the last one the wrong way around.
Yeah, it will be random as well. It won't. So you cannot access it like that. It will moan at you. So how do you access it? You access it using a for loop. So you essentially go. If I want a list here, so I can go for value in, and then I can put a value. Right. This is just going to output the same list, but that's how I access them. Right. I have to loop through them. And then I can put
your accessor at the end, right?
Yeah, well then I can put if v equals like that, and it would only output that one because I've filtered it now. So yeah, you have to, and you could use them for each and all sorts. But yeah, so that's lists. list index of objects. That's the next one. So if I go local.myObject, we've got key 1 and key 2, which is exactly the same as we've got up here. Key 1, key 2. So if I want to access a particular property, I can just put another dot and go key 1, and it'll return me that. That's cool. So that's how we do that. We've then got my list of objects, which is going to be a bit more complicated. So my list of objects, and that's going to print out everything. Because it's a list, I can use an array index. Because it's that, I can go key 1 and pull out the data that I want using that notation. So you can see as you can start building up this stuff, you can access just the data you want. So maps are used a lot. So it's worth spending some time learning how they work. My map of objects, and especially map of objects. Now, it's really important in a map of objects that all of the objects in Terraform have to have the same schema. So in this case, it has to have a key called key 1 and a key called key 2. And notice there, if I didn't have that, it would moan to say that all the values have to be the same type. So yeah, so there's my map there. Now, the way we access maps is by using this square brackets and then the map key, which is always a string. So we can access the first one in there. So we're accessing 1, then we've got key 1. And just like we did before, we can then put a dot key 1 and then get the value 1 out of it. Yeah, and that's it. Changing tack a little bit, you might have heard of ternary expressions. Now these are real basic if this then that type stuff. So let's go like local.mybool, isn't it? Yeah. So this is a thing that's set to true. But using this shorthand ternary notation, I can say, okay, if that is true, which it is, you can put this is true. And then you put a colon and go, this is false. Apart from you can't do that because, why is that? Expression was successfully passed, but extra characters were found. Oh. I don't know, that worked before. Okay, I'm going to try a different one.
Gremlins are here.
I know. My number is, local.my number is that. So if I can put local.my number, if I can put this greater than 1,000, which it is, then I'm going to put greater than 1,000. And then if it's not greater, I'm going to put less than. There you go. That one worked. Right. The other thing I can do is, I've probably just made a stupid mistake and didn't spot it. I can put that in a bracket and then go not. So if it's not greater than 1,000, so that's, I obviously could have just flipped around this as well. I'm well aware of that. So yeah, but yeah, there's lots of different ways of writing them basically. So yeah, that's basic ternary expressions. So if the expression on the left of the question mark is true or false, then do the first thing or the second thing depending on the result.
Yeah, and true is always the first, right? So it's question, like condition, question mark, true, colon, false.
Yeah, absolutely.
So it's always that way. And it's the same in Bicep as well, right? We're going to look at this in Bicep as well. It's exactly the same. So yeah, I would say like this is all really useful stuff. I would say, what's the reason we do this, Matt? Like I know me and you do this an awful lot. For me personally, it's to speed up like working out if my conditional logic or like any logic I've got within my module is manipulating the data in the way that I want it to be manipulated. And then that final value that I'm getting as an output and passing to maybe a resource or a loop or whatever is as I expect it to be formatted before I go and try and deploy resources or do anything like that and slow it down.
Yeah, absolutely. So it's exactly right. It shortens the dev loop for module development. And once you've got it correct, and once you've got your logic correct, what you should actually do is write a test. So I'll do another video on Terraform test, but that's a new feature in 1.6 that came out that's really, really good. So it's all very well testing it now when you first start your development, but then as the module changes and evolves, you need to be able to repeat those tests to say, is this still correct? Like, have I messed something up with the changes that I've made, basically? So yeah, we'll come on to that later, but yeah.
All right, so
we've shown for loops, we've shown object access, we've shown loads and loads of good stuff. There's a couple of functions I want to go through, and then I think we should do some Bicep stuff.
Yeah,
cool. So so we've got loads of functions. If you just search for Terraform functions, you'll find them out there. So and
we'll leave some links in the description so you can find these pages so you can check these out.
That's a good idea. Yeah. So might go in my object. So if you just want to return the keys, so the keys of my object are key 1 and key 2, so you can see there. So that's a good way to return a list of strings. Coalesce is one we use a lot, which is just give me the first non-null, non-empty value. So I can put null in there, empty string, and then a string, and it will return me the first one that's not empty. Obviously that's using literals, so it doesn't really make much sense. But when these values are in Terraform, and you don't know if, like, sometimes in your module you'll be like, if the caller supplies this variable, then use it. If it doesn't supply that variable, use a default value, which might be a name for something or something like that. So that's the typical function that we use. But yeah, I'm going to leave it there. I could go on all day. So yeah.
And I think this is I think, as you're pointing out, right, like Terraform console is great because you can just keep going with these functions and you're like, oh, I wonder how that works, or I wonder how this works, and do what me and Matt have done here, right? Just build out a very basic data structure of loads of different types, lots of different things in your locals. Just go and play. You can't break anything, right? Like that's the key here. You can just crack on and understand how these actually work.
There's no provider here, right? It's not even talking to the cloud. It's just all local, so it's really safe.
Yeah, and don't even need a connection to the internet, so you can do it anywhere.
You can, yeah.
So yeah, let's dive into a bit of Bicep. So as if by magic, here's my VS Code that looks pretty similar. So again, we've got things declared here, right? So we've got a string as a variable, and you'll notice in Bicep it's single quotation marks now. If I was to put double, it would say, hey, you don't need to do that in Bicep. You can use singles, all to do with reducing the amount of characters they're using. We can see we've got some Booleans declared here, some integers, but you'll note that I've got a float declared here, but commented out. If I uncomment that, you'll note that it's like, hey, you can't use this in Bicep, right? So you would typically declare them as strings, if I'm honest, in Bicep, and then manipulate them if they need to be passed in any different into the resource. But quite commonly, they're just taken as strings. We've got arrays, and you can specify these in multiple ways. And the same is true in Terraform, right? We've got a single line array, which is everything's on one line. And then I've got an array of the same thing, but it's just on multiple lines.
Oh, that's interesting. So you don't need the commas in Bicep.
Yeah, so in Bicep, we've got rid of the need for commas now when it's a multi-line array, because it knows that the new line is the next thing. So yeah, that's quite good fun, which is a bit odd when you're looking at it from like a JSON perspective. You're like, I'm missing commas, speech marks, like all sorts of stuff. Like down here, like we've got a mixed array, which we said obviously don't do, but you could do. And like I haven't had to put any commas at all. Like it's just done it. And actually, if I put a comma, it's like whoa. Like, what are you doing? Like, you don't need this. So it'll help you out. The IDE is pretty good now. We've got some objects. So we've got two objects here, both with a key and a value. We've got an array of objects, pretty similar to what Matt had. And we've also got a dictionary, so a nested object of two different objects inside there, item 1 and item 2. So let's do it a bit differently. Now, unfortunately, Bicep doesn't have like a local Terraform console concept. It is something that's being discussed in the GitHub issues on the Bicep repo. So go and add your comments over there. Like they are thinking about doing something like this, which would be great to see. But so we have to declare these all as outputs. So if I just uncomment this first one, what we're going to do is print string 1. So if I go to string 1 and I just say go to definition, we just want to print out this, right, how it is. So this is a string. So if I go down here and just go back to that output and save that, and I'm going to use the new deployments pane experience, which if you've not got the latest VS Code extension going, highly recommend giving it a go.
That's really cool.
And then I can literally say here, deploy. So I haven't got to worry about doing new AZ resource group deployment or anything like that. I can just hit here and off I go. And it will run this deployment to an ARM. So you do need a connection to an Azure subscription at this stage, unfortunately. But I can see here, outstring, return, this is a string. So perfect, doing what I want. We can do the same for an array, and I'll take out the last one as well. And let's deploy that again. And we can see what we get back here. So we should see the array at this stage outputted with no filtering or anything like that. So we've got 1, 2, and 3. And if I was to change that to the mixed array, for example, array 3, I should get back the mixed array of like 1, 2, 3 and 1, 2, 3 declared as text and integers.
This is pretty quick, isn't it? Like, it's because it's not deploying any resources. I guess this really easy way of validating.
Just throwing a blank ARM deployment effectively with just locals effectively is a good way to think about it, right? A variable is a local is a good way of thinking about it in a Bicep term. And just saying, hey, ARM engine, take this, give me an output back. You don't have to worry about not waiting for any resource providers or anything like that. We're purely interacting with the ARM deployments engine at this stage. So it is pretty quick, which is useful. You do need an internet connection though. So when you're developing on a train, like I have done in the past, can be quite frustrating. But hey, it's better than nothing. So we can see we're getting these values back. That's all good stuff. What happens if I wanted to print the first item in this array 3, right? I just want the number 1 back. So we can do the same, right? We're putting the array followed by those square brackets, and I should just get back the value of 1 here. So let's just wait for that to run. And as you can see, all I've got is the number 1. So nice and easy way to keep going with this. If I wanted to output a string, right? I think this is one thing that's key to note here, and I'm not sure if this is the same in Terraform, Matt. It's been a little while. I have to declare the output data type that it's going to get. So I have to know that at position 0 it's going to be an integer returned. Like if I change that to string, for example, it would go, whoa, that isn't a string. Like you're not going to get back what you think you're getting back. I assume that's the same in Terraform.
So outputs can have types. I recommend they do have a type, but I think there's like the catch-all any type, but I hate it. Yeah, I don't use that. So yeah, I would always be like, yeah, this is, you're expecting a string or you're expecting an object or whatever. Yeah.
No, that's good advice. And as you can see here, I've had to say that position 3 in this array, which is 4th in the list, if you think about it, because they start at 0, I'm going to get 1 back as a string. But again, if I change that to integer, it's going to be like, whoa, that's a string. You can't do that. So the IDE will help you out along the way. And that's really cool. So let's comment that
Actually, sorry, I need to correct that. The output type in Terraform is the value that you're outputting. You can't define it explicitly in the output, but you should always use explicit types in your values, not any. So yeah, if that makes sense.
No, that does indeed. So that's quite cool. So you would effectively save some characters here. You wouldn't have to type what it is, which is nice. We can do the same for outputting objects. So if we output this object here, we'll see an object with 1 attribute or 1 property. So just a key and a value. Here it is, key and value. And if we were to then follow up on what Matt was doing, we want to access that. And again, because I'm using here, I can say, hey, I just want the key, and it's reading that data for me. I can then hit deploy, and we should only see value returned for this out object attribute, which we'll see. So we see the out object, which is this one here, and we're seeing out object attribute, which just returns us value. So good way of visualizing all of this. And the same exists for dictionaries. I won't. I'll output this one here, but let's just look here. So we've got one here. Print we want to take item 2's key, right? That's what we want to see. And we know it's a string. So let's hit deploy there. And we should see both. We'll see the dictionary in its full output. So here it is. So it's, as you can see, it's got 2 items in it. And we want this value. We want item 2's key, which is this one here. And as you can see, we've got another value. So all working as we expect. Now, if I pull this back over, and you can see that's how it's declared here. We're saying we want item 2, and then we want the key. I think a difference there, right, Matt, is I don't have to declare that in square brackets. I could, but I don't need to. I can just do dot accessing.
Terraform works with both types, to be honest. So you can actually use that notation in Terraform. There are some cases where you can and can't. But what's quite nice in Terraform... Oh, can you do that? Okay, yeah.
Yeah, I think you have to then wrap it in, singles. Being bad. I could, but it's like, whoa, like you don't need to do this. Like you can do it without use dot notation.
But if item 2 is going to be a parameter or something, then you might want to use it in that syntax, so you can essentially build up that string based on the parameter. Is that a good use case?
Yeah, and like also if they've got like weird like hyphens and stuff like that in like characters that aren't natively supported in the language, and you have to wrap in strings, then you would need to do this stuff. We've had to do some of that in the ALZ bicep code. If you look in some of the policy stuff, we've definitely done it. So yeah, as you can see, it works absolutely fine. Item, and then I can use dot, and I'll get IntelliSense and say key 2. So like all fairly easy stuff. I just need that to be key because it's not a string. But as you see, it all output absolutely fine. Let's get a little bit more complex though, right? So this is something that I don't think you have in Terraform, but is something that exists in Bicep. So sometimes if we look at this data type for this dictionary, let's say that you said, Matt, that every item in a map in Terraform has to be the same, has to look the same.
Every value has to be the same, yeah.
Yeah. So, for example, in here, if I was to say key 3 existed in one of these items, but not in another, in
Mm.
Terraform, would that kick off? Or would it be like, that's fine?
If the key didn't exist at all, yes, it would. However, most people would just set it to null. But yeah, you're right. If the scheme is different, it will complain.
Yeah. So in Bicep, I can have that where it might exist in one, but not in the other. And that's okay. And you need to be able to handle that sometimes, right? It might not be passed in as a parameter. So what we can do here is something called a safe accessor. So you'll notice there's this question mark after the item before
Mm.
the property name. So before key 3. Now, obviously, it's saying, hey, key 3 doesn't exist. The IDE is getting well ahead of itself and being useful. So it doesn't exist. But what I can say here is if key 3 doesn't exist, this is coalesce, shorthand for coalesce in Bicep. So I could type out coalesce as you did.
Mhm.
Return this. So we know
Okay.
key 3 doesn't exist in this
Yep.
dictionary here in item 2. So we should get back just the default value. So if we hit
Okay.
deploy,
So while that's doing that, is that safe accessor, if you didn't have that coalesce, would it just return null?
if I didn't have, no, it would fail.
Oh, right. Okay.
So it'd
Right.
fail the answer point because it'd be like, there's no value. Like, what do I do? Like, and it
Okay.
would fail. So this is why it's a fairly new thing to Bicep, but really really useful when you, especially
Mm.
when you don't know what the object you're getting in is coming or could be different. You can basically say, well, if it doesn't exist, then do this. Right. So a bit like the same example, which is another way of handling.
Yeah.
Before we would have to have done like a loop and gone like, if it's empty, then do this.
Right.
Right. And it got long. So this is a
So
really quick way of defining it. And if you look at a lot of our AVM code samples, we do exactly this
okay.
for a lot of
So
our inputs.
in Terraform, we have a lookup function which can do similar things. So you can say, look, if this key exists, then return its value. If it doesn't, then give me a
Then give
default.
this.
So yeah.
Yeah, and this is effectively the same way of doing that, right? Just the Bicep flavor of doing it. But again, really easy way to quickly test what this function is doing. A couple more, and then I think we'll wrap it up. But let's
Yeah.
have a look at a ternary condition, right? So the bool 1 is currently true. If we go to its definition, bool 1 is true. If we go back down to the output, we're going to say, hey, if bool 1 is true, then return bool is true. And if it's not, return bool is false. Right. So very similar to what Matt was doing and very similar syntax, like identical almost. Right.
Mm.
So a lot of these things you'll find are same across languages. And if we look here, bool is true. Fantastic. Now I could do the same as Matt. I could say not, and I could put an exclamation mark, and that would flip it, and that would work as well. Or I could actually type not and wrap it in brackets, but that's just a shorthand way of accessing it in Bicep. So we should see this is now bool is false because we're negating the first one. And we can do, mathematical, like is int 1 less than 10. So int 1 is currently 1, as we're seeing here from the IDE. So int is less than 10. And the other one will say int is greater than 10. So let's hit deploy on that and drag this back out. And we'll see in a second, int is less than 10 because it's 1. So perfect, we're seeing that. Right, very, very easy stuff, and much easier to write in Bicep than it was back in ARM templates, which is great to see.
Oh yeah.
And we've got the
And
same things here, so I'll just show all of these very quickly. Like we can do some mass, we can do some uppercasing, like to upper, and we can do some complex stuff like a lambda function that's like, hey, just give me key 2 back out of every item. I don't want to see anything else. I just want key 2 out of all of them and give me it as an array. So we'll do a bit of a grouping of outputs here for time. So we should see an uppercase string of string 1. We should see int 1 and int 2 added together and get the resultant value. And we should see an array with only items from the array of objects, which I'll show you up here very quickly. So this array of objects, where we only want key 2 returned from each object in this array. And so if we now look down here on the right-hand side, this is a string has been capitalized or uppercased. We've got out maths added together because it was 15 plus 1 from the integers. And we've got the array of true and false, which is just the values of both of those keys that we were looking at just up here. So true and false. So yeah, that's it. So very, very similar, but again, one more step, like it has to connect to Azure and you have to have a scope to deploy to. But still fairly quick dev loop, really easy for me to go and test out my logic. And when I'm testing really complex stuff, and I can't get it working. And I'm like, right, I just need to strip this back to basics. I'll rip out the data into a local bicep file, and then I'll just start doing this as deployments and forget about deploying resources, get my data working, and then when it's working, put all the logic back and start trying to deploy my resources just to try and speed up getting the time to the fix.
That's really cool. It's really great way of speeding up your dev process.
Absolutely. Well, hopefully people have got some real value out of that. I appreciate there's a more lengthy one, but we'll chapter this up so that you can skip between which language you're interested in. Any last passing thoughts, Matt?
No, I do wonder if we should maybe make the test files available somewhere on a GitHub gist or something, so we can put the link in the description maybe if people want to take it.
Yeah, absolutely. It's a good idea.
So I hope you enjoyed that. This video has been cross-posted on the CAE YouTube channel, and the links will be in the description below, along with the GitHub gists and everything else that we have used. If you've enjoyed this video, please consider liking and subscribing, as it would really help me out. Thank you, and see you next time.